Hello, my dear students. Welcome to 9th standard science class of online lectures in our YouTube channel. This is RV Jambagi. In the last class, we learned uniform and non-uniform motions, their meanings, and some examples. We also learned scalars and vectors, their definitions with some examples. Illustrations to show the clear idea of a scalar and vector, and at last we differentiated scalars and vectors respectively. In the lecture today, we are discussing some important terms of motion such as distance and displacement with illustrations. So, allow me to begin this class. Important terms related to motion. To understand the motion of the object, we need to study the terms such as distance traveled or path length, displacement, speed, velocity, and acceleration. Let us try to understand those terms one by one. First will be distance traveled and displacement. So first will be the distance traveled. The actual path or length covered or traveled by the object or a body between the initial and final positions is called as distance traveled by it. The actual path or actual length covered by the object between initial and final positions is called as distance traveled by it. Assume a body starts moving from point A to point B and B to point C. Okay. The distance traveled by the object right now is from A to B, then from B to C. Therefore, the actual path will be AB plus BC, and hence distance traveled is equal to actual length or path covered. I hope you got this definition right. Next one, displacement. The shortest length covered or traveled by the object or a body from initial to final positions is called as displacement. The shortest length covered or traveled by the object from initial to final position. See here, take the same example, that is A, B, and C respectively. The distance traveled is AB plus BC. Displacement means what? That is the shortest length covered or shortest path covered. How do you calculate here in this example here? That has to be the direct path, initial point A and say initial position A to the final position B. This has to be the displacement. This has to be the displacement. Distance traveled is AB plus BC, where displacement is AC, and hence displacement is equal to final position minus initial position. So this is about displacement. I hope you got this one right too. Okay. Let us take some illustrations to study the distance traveled and displacement respectively. First one, assume a person is moving from one place at point A straight to point B. Later he moves to south and reaches point C. Okay, the same example here which I quoted earlier, but in different manner. So this is the point A. A person starts walking from point A straight to point B, and he moves to the southern direction to the point C. I can draw like this. Moving towards south means at the bottom in the screen. So he reaches at the point C. Okay. So we are going to calculate, or we are going to find out the distance traveled by the person and displacement of the person. Okay. I hope you got this illustration right. Now, then the distance traveled by him is the actual length covered by him. Actual length covered by him with respect to that figure, that has to be AB plus BC. That is the actual length covered by the person, and hence that has to be the distance traveled D. Distance traveled by the person, that is equal to D. And what will be the displacement? That is the shortest length, and it will be AC according to that. So AC will be the displacement. So join the points A and C. AC has to be the displacement. Okay, that is the shortest path. AC will be the displacement. You call it as X. Okay. So actual length covered by the person is AB plus BC. That will be the distance traveled by him, and displacement will be simply AC. Let us add some values to the above case. We have the picture AB to BC. So this has to be the picture ABC. So we can add some values here. A to B is 3 km, B to C is 4 km. Then you have to find out the distance traveled as well as displacement. Okay. The distance traveled D is given by D is equal to what? That has to be AB plus BC, which is equal to AB is 3 km and BC is 4 km, and hence the distance traveled by the person is equal to 7 km. 7 km will be the distance traveled by the person. Now, for the displacement, we are taking the Pythagoras theorem, since it is the path of that person is simply a right angled triangle. So we can apply Pythagoras theorem, that is given by AC square is equal to AB square plus BC square. This is as per Pythagoras theorem. Okay. So according to the Pythagoras theorem, AC has to be the least distance, and hence that is considered as displacement of the person, and hence it can be written as AC is equal to under the square root AB square plus BC square, which is equal to, we already know the values of AB and BC respectively. You can add here. So 3 km plus 4 kilometer square of these. Okay. Therefore, 9 plus 16, which is equal to 25, and hence that has to be the 5 kilometer. So the displacement, as I said, that you can say it as AC, which is equal to x, and hence x, the displacement, which is equal to 5 kilometer. X is equal to 5 kilometer, and hence displacement will be 5 km. Therefore, you can say that the distance traveled is equal to 7 kilometer, and displacement x is equal to 5 kilometer. You can note directly here that the distance traveled and displacement are not same. Distance traveled and displacements are not same, and hence distance traveled is the actual path covered, whereas displacement is the minimum or least distance covered. Let us take the second illustration. A honeybee is flying in random motion. After tracking its path by referring to the following figure, it should be from O to A, then A to B, then B to C, C to D, and D to E respectively. Then the distance traveled by the honeybee, that will be the actual path covered by honeybee, which is equal to the distance traveled D. Therefore, that is equal to OA plus AB plus BC plus CD plus DE. OA, AB, BC, CD, and DE will be the path length or the distance traveled by the honeybee. Okay, and amongst the shortest path, the displacement, that is equal to x, that x is equal to OE. OE will be the point O to point E, that is OE equals to OP, this is OP plus PQ, then QE. So that is the shortest length, and hence the displacement of the honeybee will be equal to OP plus PQ plus QE, which is equal to X, or you may say OE. Let us add some value to the above cases. Let us bring back the values for the distance traveled. Distance traveled by the honeybee is equal to simply D, which is equal to OA plus AB plus BC plus CD plus DE. So substitute all these values over here. O to A means OA, which is equal to 3 meter, plus A to B means AB, 4 meter, plus BC, 5 meter, plus CD, 10 meter, plus DE, 5 meter. So you take it as take a common value for meter here, which is in meter, and hence 3 plus 4 7, 7 plus 5 12, 12 plus 10 22, 22 plus 5, that is 27 meter. The distance traveled of a honeybee is equal to 27 meter. Similarly, the displacement x, displacement is taken as x here, which is equal to simply OE. OE is equal to how much? OE is equal to OP plus PQ plus QE. So again the values are taken over here. O to P, that is 3 meter plus 4 meter plus 3 meter, and hence the displacement of the honeybee is equal to 10 meter. 3 plus 4, 7, 7 plus 3, that is equal to 10 meter, and hence the distance traveled by the honeybee is 27 meter and the displacement of the honeybee is 10 meter. I hope you followed this illustration cleanly. Next illustration, a body is moving in a circular path of some radius. With respect to the figure here, it is from point K to L, L to M, M to N, and N to K. It is again moving to the same point where it is started. Okay. Then the distance traveled by the body equals to circumference of the path. So circumference of the path, which is equal to C, and displacement, interestingly in this case, is 0. Okay. The distance traveled by the body is equal to the circumference of the circular path, generally circumference of a circle, which is equal to C equals to 2 pi r. Now let us take the radius of this circular path is 7 meter. If you take the radius of circular path as 7 meter, then the distance traveled is given by distance traveled is equal to, that is D, which is equal to circumference of the circle C or circular path, which is equal to 2 pi r. Since r is equal to 7 and pi is equal to 22 by 7, therefore this is equal to 2 into 22 by 7 into 7, which is equal to, so 7 get cancelled here, and hence you left out with 2 into 22, which is equal to 44 meter. So the distance traveled by the body is equal to 44 meter. Okay. And as I said that the displacement of the object or the body, which is equal to x is equal to 0. We are always defining displacement as it is the least distance. Therefore, it can be calculated from final position minus initial position. Final position minus initial position. So the object in the case is returning to its path. Therefore, I can say that the displacement of the body is 0 because it is starting from the point K. The body's motion is starting from point K and it is returning to the same point K, and hence there is no initial and final positions, and hence they cancel each other. Therefore, we left out with 0. Displacement is 0 and the distance traveled by the body is equal to 44 meter. And hence the distance traveled by the body is equal to 44 meter, whereas the displacement is equal to 0. I hope you followed all these illustrations right. This ends today's lecture. With some more videos, I will meet you in the next period. Till then, take care of yourselves. Bye bye.